Hey guys, welcome to lesson one, and this is the first lesson in our new unit, unit three. We're actually going to, I'm currently done, and we're going to actually cover lessons one and three in the book. So we're going to kind of kill two birds with one stone. This lesson is actually going to be in two parts, but for right now, I just want you to worry about this part here, and then we'll cover the second part in class. So remember on the unit circle how we have like the part, like the lines that I told you not to worry about, not to fill in? Well, we're going to talk about that today. They are called radians. And radians are just another way to explain degree measurements. So like you can either say, like say 30 degrees in degrees, or you can say it in radians. And there's a very specific reason why we have radians I'll get into later. But a radian is just like another way to express that. So a radian, here's the definition. A radian is equal to the measure of the central angle theta that intercepts arc S. Okay, so what this means, I drew a picture over here. What this means is in this triangle right here, when this radius length is equal to this length right here, when those are equal, your arc length is going to be S, and that is going to be equal to 1 radian. And so it's kind of confusing, but what this is, so if you want to think about this, if I took, so if we could do fun stuff in class, I would take like a Twizzler, and we would measure out the Twizzler, and then we would take that Twizzler and we'd put the Twizzler around the circle. And what you would find is that we would go over a little bit over 6 Twizzlers. In fact, in a perfect world, you would have 6.28 Twizzlers. And how you get this is would be equal to like about 2 pi. And so it very much has a lot to do with the circumference of a circle. And in word problems, we can't put in 360 degrees because it's not like something that we can measure in a word problem, but we can put in 2 pi radians. So that's the main reason for radians. A couple things I want to point out. The variable for radian is S. So that's where that's coming in as well. And I just want to say the conversion. So we have 1 radian is equal to the radius. Oops, right? Which is equal to arc. So this is your arc length. It's equal to 1 radius, or 1 radian, I'm sorry, which is equal to the radius. So all of those are sequences. Okay, so let's kind of jump into this. I think it'll make more sense. So remember, in the unit circle, our r equals 1. And we have, if you think back to geometry, the circumference of the circle is 2 pi r. And so since r equals 1, the circumference, if we went all the way around the circle, that would be 2 pi. So that kind of goes back to what I was saying about the Twizzlers here. So that means that 360 degrees is equal to 2 pi. So like pi, that would be equal to 180 degrees, and so forth and so on. So we can break it down super specifically, even to the degree. So if we're going from radians to degrees, we are going to take 180 and we're going to divide it by pi. That is going to be our conversion. So radians to degrees. If we are going opposite, if we're going from degrees to radians, we are going to do the reciprocal of that. It's going to be pi over 180. So let me show you how this works here. So if I wanted to, well, let's take this one, for example. We know the answer to that one. So So I want to go from radians to degrees. So I'm going to multiply by 180 over pi. The pi's cancel out, and I get 360 degrees. So let's try it with this. So it says convert each degree measure to radians, keep in terms of pi. So what that means is when I multiply by, oops, sorry, we need to go the other way for this. Anyway, when I multiply by pi over 180, because I have this one, I don't worry about the pi, I'm going to keep it alone, leave it alone. So it ends up being like that, and then I'm just going to simplify that fraction. And if you have a graphing calculator, if you use math enter, that will get that into a simplified fraction. So I would put like 480 over 180 into my calculator and math enter, and that will give me 8/3. So my answer is going to be 8 pi over 3. This negative, sometimes people don't know what to do with it. It's just like translating from like English to Spanish, or in this case, degrees to radians. And so it's just going to stay the same. I'm not having to add 360 to it or anything like that. So I'm going to look at this as 225 pi over 180. And again, I'm going to simplify that, and it ends up being negative 5 pi over 4. So go ahead and try these next two. Okay, so you should have gotten 29 pi over 60 once it was simplified, and negative 47 pi over 60. So we don't need that. That's a repeat of what we just did. Sorry about that. Okay, now these, we're going to go from radians to degrees. And so if we have to, we're going to round to the nearest 10. But a lot of these we won't have to, so I'll show you that. Hey guys, I realized that I did not make a mistake. I forgot. Sorry. This one, instead of keeping it in terms of pi here, I want to round to the nearest 100. So you're going to kind of use both ways. So let's take 480, for example. So right here, you could just type this in your calculator if you wanted to, but in reality, you're probably going to have a problem that you need to take it from here. So just make sure that you can type in your calculator correctly. You should get about that. So do the next 4 and make sure you can do that. Okay, so this is what, these are what your answers should be. And again, like you can take them from here, but make sure that you can do it from the original number as well. Okay, now let's go the other way. So we have radians degrees. So in this case, we're going to multiply by 180 over pi. So what happens is that these pi's cancel out. So I get 180 over 6, and that ends up giving me 30 degrees. Okay, so try the rest of these, and we'll see how that goes. Okay, so here are your answers for all of these. So on this one, I want to make sure that you can get that. So look on your calculator for DMS, and we've kind of talked about this in class, but if you're still having issues with transferring from decimal degrees to degrees, minutes, seconds on your calculator, come find me and I'll help you figure it out on your calculator. But this is the rest of your answers for that section. So now that we're pros at doing radians, I want to look at the unit circle, and we're going to fill in that other missing piece that we haven't talked about yet. Okay, so these are just like the degrees on here. And so we talked about if you went all the way around the circle, I'm going to do this in a different color. If we go all the way around the circle, that's going to give us 2 pi radians. So that's the same thing. Okay, well, if we go halfway around the circle, that is going to give us pi. And if we go, and this is 0, so if we go halfway between 0 and pi, that's going to give us 1/2 pi, or we're going to call this pi over 2. So now let's look at pi over 2 and 0. Halfway between that is going to be pi over 4. You don't have to do this every time, but I'm just wanting to get your mind into it. So what I want you to do is think about 30 degrees and then go back to what we've talked about. So we're going to multiply by pi over 180. So I get 30 pi over 180. And I'm going to simplify that. So remember 30 divided by 180, math in our inner, is pi over 6. So this one is going to be pi over 6. I want you to do the rest of them either by, kind of thinking your way through it or using this conversion rate. So this is what it is all the way finished. Notice that all the 30-degree angles, so I'm going to circle them, they're all over 6. And so think about every 30 degrees, here's 1 pi over 6, 2 pi over 6, 3 pi over 6. So notice I'm going up by 30s, 30, 60, 90. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. And notice 2/3 is 4, 6. 5 pi over 6, 6 pi over 6. So when you go by 30s, you're going up by 1/6 every time. When you go up by 45, that's going to be 1/4 every time. So 1/4, 2/4, 3/4, 4/4. So there's some patterns there that you can fall back on. So we're going to like move back and forth. So sine of 5 pi over 6. So what we're going to do is we're going to go down here and figure out where 5 pi over 6 is first of all. So if you'll notice, 5 pi over 6 is right here at 150 degrees. So you can either look at it as the sine of 5 pi over 6, or you can also look at it as a sine of 150 degrees. So in our last test, you would be able to do this. So we would have all of these filled out, which I'm going to do here in a second. So we're just going to look at the y value right here. So I'm going to do two things. I'm going to fill this out, and then I will talk about the answer. Okay, so I filled this out. So we're right here again, and so our answer is going to be 1/2. So I'm going to come up here and just type in, or just write 1/2. Let's do a negative. So negative pi over 2. So this is positive pi over 2. So I'm looking at negative 90 degrees. So I'm looking at right here, first of all, and it is cosine. So our cosine is going to be our x value. So my answer is 0. Oops. So on this one, I already know that this is too big. So you can do one of two things. You can either subtract 2 pi from it, or you can just figure out this as a degree and subtract 360 degrees until you get to where you need to go. And it's just about using the unit circle as a reference. So you can see I did it the radian way. And so I had to actually subtract 8 pi over 4, which is 2 pi, 2 times, and I got pi over 4. So I'm looking at a 45-degree angle, and I'm looking at the tangent of 45 degrees. So it's just 1. Okay, so what I want you to do is play around with all of these and see what you get. Okay, so these should be your answers for all of them. And as always, if you have any questions, just let me know. And that is it for part 1 of this lesson.